Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range. This is standard A.6A in the great state of Texas, and we are using item number 32 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got part of a quadratic function here. On this grid, we notice it does have a starting point right here, and it kind of loops down. It looks like we've got our minimum right here. If we wanted to, we can kind of see our axis of symmetry, or at least what the axis of symmetry would be if we were to continue. It's not quite symmetrical because we've stopped that quadratic at x equals 5. So we need to find the domain. All right, so we always talk about domain and range together. Right? And so let's make sure we understand which one is which. So your domain is your set of all input values. And so our input values are typically going to be our x values, whereas our range, we normally will talk about them both together. Those are going to be our output values. And those are typically your y. But sometimes, right, it becomes an f of x or a g of x, or if we're dealing with function notation. So that can change sometimes. We're dealing with domain, which means we're focusing here on our input values. All right. And so let's look at our x. Let's look at our x terms. And so we notice that we do have this stopping point right here. So we've got x equals 5, and we can include that because it is a closed circle. And then anything to the left of that, okay? So anything to the left of x equals 5 or smaller than x equals 5. So I'm going to change this equals to, I'm going to change it to less than or equal to 5. And the reason I'm doing that is because I can include 5 in my solution set. If it were an open circle, I would need to just make that less than 5. And then I'm simply looking left and right. I'm looking at my x values. It's going to go left or right all the way up to 5 and then stop. So I'm looking at x is less than or equal to 5. That's how I would do it if I were to write it out in this inequality notation here, but all of our answers are in words. So let's see if we can translate those into this notation here and see if we can find one that is x is less than or equal to 5. So I'm going to change colors here. All real numbers less than or equal to 5. So we're going to say all real numbers, if we're looking for x, right, less than or equal to 5. Okay, well, that's exactly what we think it is. So I'm thinking it's going to be A, but we need to go ahead and let's go ahead and look at B, C, and D just to make sure that they are incorrect. B, all real numbers greater than or equal to 3. Okay, so X is greater than or equal to 3. Well, here's my 3. Ah, look what they did here. All right, so that is actually my minimum, or at least the X value of my vertex, right? And so that's where they pick that 3 up. But if we're doing all real numbers greater than or equal to 3, then it's going to go this way. And obviously we've got a problem because it stops right there at x equals 5. So we really only have, between 3 and 5, we just have those two integers gap there if we're counting by ones. So that's not going to work. All real numbers greater than or equal to 1. And they're just getting this 1 right here. I'm not sure why they chose this 1 because it looks like it kind of lines up with that y equals 5. But if we're doing this, maybe it's because it is equal to that height is equal to the stopping point across the way. So you're just trying to get all real numbers greater than here. But first off, it's not all real numbers because the graph doesn't continue and it misses all of this. So that's not going to work either. And then all real numbers is not going to work because we've got this hard stop at 5. It's not going to be all real numbers. So it is going to be A.